All right, here we go, people. We're continuing on. Maybe you'd like it if I zoomed in a little bit. Maybe that would help. I don't know. All right. If we want to make 90 grams of gallium, so that will be right here. So 90 grams, first of all, let's convert that. Okay, 90 over 1 times 1 over, let's look up gallium. Okay, gallium is 69.7. Say 90 divided by 69.7 equals 1.29. So 1.29 moles. How many grams of gallium oxide should we add? All right, here's gallium. We have 1.29 over the 4, and the gallium oxide is what we're solving for, so x over 2. So we're going to say times 2 divided by 4 equals 0.65. 0.65 moles. But the question was, how many grams of gallium oxide? If we look at gallium oxide, that's going to be like 140 plus 48, like 188. I know it's a little bit off. We're looking at something around 121 grams. I just did that one in my head, kids, so it's probably just a little touch off. All right. How many liters of oxygen gas? All right, how much of this? So how much of that? X over the 3 right there. Or at least when 2 moles of gallium oxide are added. 2 over the 2. So 2 over 2 equals x over 3. The x is going to be 3. But it said how many liters? 22.4 liters per mole. 22.4 times 3. 67.2, like it always is. 75 grams of gallium oxide. Let's convert that to moles. 75 over 1 times 1 over 188. All right, 75 divided by 188 equals 0.398, 0.4. How many grams of gallium metal is produced? So we have 0.4 moles of gallium oxide. 0.4 is to 2 as X is to gallium. 4. 0.4 over 2 is that we're going to cross multiply times 4 divided by 2. 0.797, so 0.8. How many grams of gallium metal? 0.8 times 69.7 times 69.7, 55.6 grams. All right. If 5 moles of gallium were produced, okay, so 5 over the 4. How many liters of oxygen were produced? Equals x over the 3. 5 over 4 equals x over 3. Cross multiply. 5 times 3 divided by 4 equals 3.75. But it says liters. 22.4 liters per mole times 22.4 equals 84 liters. All right, keep rolling. This one's already balanced. It's 111. 15 liters of chlorine gas are added. 15 over 1 times 1 over 22.4. Figure out how many moles that is. 15 divided by 22.4 equals 0.67. 0.67. So 0.67 is to 1 as how many grams of calcium chloride? X is to 1. So again, it's 0.67 moles. Calcium chloride is 111 actually if you add it up properly. 111 grams per mole times 111. 74.3 grams. If 2 moles of calcium chloride were produced, okay, so if there's a 2 here, right? 2 over the 1. How many grams of calcium were used? X over 1. 2 over 1 equals X over 1, so obviously the X is equal to 2. Let's say grams of calcium. Calcium weighs 40 grams per mole. Whoops, I'm writing off the board there. Sorry about that. 2 times 40, 80 grams. All right. If we added 50 grams of sodium carbonate, all right, 50 grams, let's see, sodium carbonate is 46, plus 12 is 58, plus 48 is 106. 50 times 1 over 106. 50 divided by 106, 0.47. 0.47 moles over 1 equals, we're measuring, oh, this is for honors only, kids. No, we're on percent yield. Let's see how many grams of sodium oxide we should make. 0.47 is to 1 as 0.47 is to 1. So we should make 0.47 moles of that. 0.47 times, let's see, that would be 46 plus 16, that would be 62. 0.47 times 62 equals, we should have made 29.2 grams in the perfect world. However, we only made 20. So we only made 20 out of that. 20 divided by 29.2. It was a 68% yield. If we added 55 grams of sodium carbonate, okay, 55 over 1 times 1 over 106. Let's figure out how many moles that is first, right? 55 divided by 106, give me 0.52. So 0.52 over 1, and we collected 10 liters. What's the percent yield of carbon dioxide? So we need to figure out how many moles of carbon dioxide should be made. Well, guess what? 0.52 over 1, it was X over 1. Should have made 0.52 moles. Multiply that times our liters to figure out how many liters we should have made, times 22.4. We should have made 11.6 liters, but the problem says we only made 10. We only made 10 out of 11.6. 10 divided by 11.6 equals 0.86. 86%. Okay. This is for the honors kids right here. I'm going to skip that. And then back here, empirical formula. All right. Empirical formula. We have a molecule. It's 46.6 nitrogen, 53.3 oxygen. What's the empirical formula? We're going to pretend these are grams. Nitrogen, we'll divide that by 14. We'll divide that one by 16, respectively. 46.67 divided by 14 gives me 3.33. 53.33 divided by 16 gives me 3.33. Guess what? This formula is just nitrogen monoxide. That's a 1-to-1 ratio. Those are the same number. A molecule is 75% carbon, 25% hydrogen. 75% carbon, we'll divide that by 12. 25% hydrogen, we'll divide that by 1. That's crazy. 75 divided by 12. 75 divided by 12 gives me 6.25. 25 divided by 1 gives me 25. This is the smallest one. So our carbon's going to be a 1. And 25 divided by 6.25, it's going to be a 4. Hydrogen's going to be a 4. That's methane. You've seen that formula a bunch of times. CH4 is the formula. Honors kids, I'll make a separate video for the limiting reactants.